Hello everyone. I hope you all are doing good. This is Lakshmi Narayana, Senior Physics Faculty. Okay. Before starting the section, if you have any doubts, please comment in the chat box. Okay. So we are on time. Let's wait for a few more seconds to join the class. Okay. So before that, you have to think which topic we're going to discuss in today's section. Okay, I hope you all are excited to follow the classes under. Okay, just think about which topic we're going to discuss in today's section and which is pending. If you are following the classes regularly, which is pending and which one we completed and which is the pending. Okay, so just wait for a few more seconds. Other than that, we will start classes after a few seconds. Okay. Without any delay, can we start? Yes. Can you guess the topic which is we're going to discuss in today's section? Anybody guess? Huh? Okay. Electricity. Okay. The most important topic and related to the real life. The most especially physics is related to the real life only. But without this, without electricity, we can't do any work. Even you not listen the classes also. Okay. So, are you excited to follow the classes? Are you excited to hear about the electricity chapter? You all are excited? I am also so excited. Okay. Yeah. So, without any delay, can we continue? Electricity. Okay. What is electricity? You have an idea about an electricity, right? If any electronic devices has to work, the electricity is required, right? For example, mobile phone, electricity is required. Panel, electricity is required. Camera, electricity is required. Bike, electricity is required. So, in everyday life, electricity is also one of the part. Okay, yeah. See, what are the topics we're gonna cover in today's section? What topics are there? What are the topics? We're gonna introduction of charge. Okay, the basic one is that introduction of charge. Then after we will discuss about conductors, insulator and semiconductors. What are these? What are these? What is conductor? What is semiconductor? What is insulator? Okay, so these all are the types to pass the electricity from one place to another place. Okay. Next, electrical current and circuit. From here onwards, our section begins. Okay. From electrical current and circuit onwards, our section begins. Previous one, just recapped. Next, electrical potential and potential differences are there. Okay. What is electrical potential? Okay. If current passes from one point to another point, how the potential will be? Is it same or variate? We will discuss in this. Next, circuit diagram. The really circuit diagram is required to pass the electricity or not. Okay, what type of circuit diagrams are there? Whether open circuit or closed circuit, which circuit is required? Next, Ohm's law, the main important topic. For further classes also it will be very useful. Okay, what is Ohm's law? Okay, next, factors on which the resistance of a conductor depends. Okay, if you take what is resistance first of all, okay, you should know what is resistance and what factors are there. Next, summary. Okay, okay, yeah. Next, see, charge. Charge. So many of them know about charge. Okay, what is charge? What is charge? So charge is the basic property. What is charge? It is a basic property. If you take any material, how it forms? It made up of atoms or molecules, right? Any substance like pen, remote, book, table, any material, it's made up of atoms or molecules, right? So in atom, what it is present? Subparticles are present. What are the subparticles? Proton is present, electron is present, neutron is present. Okay, subparticles, where are these present? What it is present? Protons, electrons, neutrons. What is the charge of the proton? Positive. What is the charge of the electron? Negative. What is the charge of the neutron? Neutral charge. Okay, charge is what? It's a basic property. Okay, it's a fundamental property of matter. It's a fundamental property of matter. There is no matter, no charge. No matter, no charge. If you need charge, the matter has to present, either solid or liquid or any other. Okay, so matter present, charge is also present. No matter, no charge. Okay, if definitely charge is required, matter is present. The matter is present without charge also, that is possible. Okay, matter present means charge is present. Without matter, no charge. But with matter, if the matter is present, the charge is not required. Charge is now what? It's a fundamental property. Charge is what? It's a fundamental property. Okay, or intrinsic property, because it's present inside only. Intrinsic property. Okay, it is intrinsic property. Protons, electrons, neutrons exhibit electrostatic attraction or repulsion in the presence of other matter with charge. Attraction is present. Okay. Repulsion is also present. Which particles attract? Opposite charge particles are attract. Same particles repel each other. Same particles repel. One positive, another positive repulse. One positive, another positive repulse. Okay. Positive, positive repel. Negative, negative repel. We know na. Okay. Which particles attract? One positive, one negative. Both attract. Okay, both attract each other. Next, what is the SI unit of electrical charge? Remember, SI unit of electrical charge is coulomb. What is that SI unit of electrical charge? Coulomb. CGS unit is ESU, electrostatic unit. Okay, we have two units, SI unit, CGS unit. SI unit is what? Coulomb. CGS unit is that electrostatic unit. Okay, ESU. In 1 coulomb, how many electrons are present? 6 into 10 to the power of 18 electrons are present. How many electrons? If I am taken a body, okay, I am taking a body. I am taking A is a body. On this body, let us consider 1 coulomb charge is present. How much charge is present? 1 coulomb. 1 coulomb charge is 1 coulomb. 1 coulomb charge is present. In this 1 coulomb of charge, how many number of electrons are present? How can we calculate? We have a formula of quantization of energy. Q is equal to Ne. Q is equal to Ne. Remember, Q is equal to Ne. Charge. Q is what charge? How much charge particle? 1 coulomb charge. Number of electrons that we don't know. N. Electrons. 1 electron is 1.6 into 10 to the power of minus 19. Na? Minus 19. Na? Then N value you will get 1 by 1.6 into 10 to the power of minus 19. Then you will get 6 into 10 to the power of 18 electrons in 1 coulomb of charge. If anybody asks you, in 1 coulomb of charge, how many electrons are present? How many? 6 into 10 to the power of 18 electrons are present. Okay, next, 1 electron as a negative charge, that is 1.6 into 10 to the power of minus 19. Okay, 1.6 into 10 to the power of minus 19 coulomb. 1 electron. In 1 coulomb, 6 into 10 to the power of 18 electrons are present. Remember. Okay, in mathematical calculation it will be helpful. Next, conductors, insulators, semiconductors. What is conductor? What is semiconductor? What is insulator? Okay, conductors means which allow the charge. I am a conductor, not means not giving a ticket. Okay, conductor means if I touch the electrical board, the electricity passes through my body or not. If it is passes, I am a conductor. I act like a conductor. Okay. If it is not passes, I am an insulator. If you see any persons doing a work, electricity work, what they will wear? Gloves they will wear, right? Chappals they will wear, right? Why? Because it's an insulator. Insulator means it doesn't allow. Conductor means allows. Okay. Conductors means allow. Conductors means allow. Insulators do not allow. Opposite, completely opposite. That way electrical persons wear always insulating materials. If you see a wire also, okay, a copper wire, it coated with insulating material. Okay, insulating material is there. Okay, the insulating material is protection from the electrical shocks. Next, semiconductor. Semi means off, allow off, allow off, stop off. Okay, allow off, stop off. Okay, so we have two types of semiconductors, silicon and germanium. And insulator we have many. Rubber is there, plastic is there. Okay, so these all are insulators. Wood is also insulator. Next, conductors means all metals. Conductors means all metals. All metals are act as a good conductors. Okay, metals, conductors means allow. Insulator means completely opposite, doesn't allow. Semiconductor means allow, off only. Off only. For suppose 10 amperes of current passes, it allows 5 amperes. Remaining 5 amperes doesn't allow. Okay, like that, remember. Next, electrical current. Okay, what is mean by electrical current? For example, I am taking a one material. I am taking a one material here. This is the area of that material. Area of that material. Okay, charge is entering into the material. Okay, charge entering into the material, and here it is that leaving the material. Here it is enter. Here it is exit. Okay, entering time t is equal to 0 seconds. Leave the time t is equal to t seconds. Okay, in time of t seconds, what is the charge? Charge will flow na. Charge passing through unit area, right? Here I am taking a conductor. Charge passing through unit area. Charge passing through unit area is called electrical current. Okay, what is electrical current? Flows through a conductor. We say that there is electrical current in the conductor. Okay, if the electrical charge, which charge? Electrical charge. Electrical charge flows through the conductor is called electrical current. Simply current means flow. Current means flow. Okay, current means flow. Which is flow? Charge is flow. The charge flow through unit area is called current. Simple. Electrical current. Electrical means charge. Current means flow. Electrical current means charge flow. Electrical current. Simple. Okay. Or else we have one more also. Electrical current is amount of charge. Amount of charge, particular unit area in unit time. Let us see here. How much time taken? In time of t seconds. Okay. How much charge? Amount of charge. Charge per unit time. Charge per unit time is called current. Charge per unit time is called current. Okay. Look at the formula. The rate of flow of electrical charge. Charge per unit time. Charge unit, coulomb. What is the unit of charge? Coulomb. What is the unit of time? Second. Coulomb per second we call as ampere. Okay. Remember. Coulomb per second, what we call? Ampere we called. Coulomb is what? It's a unit of charge. Second is what? It's a unit of time. Coulomb per second. Coulomb, charge per unit time. Charge per unit time. Take a conductor. Charge passing through the conductor. And how much time taken? T t seconds, this charge per this time, you will get the current, the flow in the conductor. For example, if I got electrical shock, charge passing through my body, okay, charge passing through my body, how much time taken? For example, let's take less time. If you take more time, that's it, okay, just take less time, because if current passes continuously through my body, what will happen? Guess what will happen? My nervous system will completely back, right? Completely doesn't work now. Okay, so if someone help me to live, okay, so how much time? Let us take 2 seconds. 2 seconds, charge passes. Charge passes. 2 seconds. That is called current. Electrical current. How much time, how much current passes through my body? How much charge is present in a given time? Okay. Next, unit. What is the unit of current? Ampere. What is the unit of current? Ampere. Okay. Next, electrical current is defined as flow of charge. Okay, and unit ampere only. 1 ampere. 1 ampere. 1 ampere. 1 ampere means 1 ampere. Ampere is what? It's a unit of electric current. Ampere is what? It's a unit of electrical current. So electrical current formula is what? Coulomb for time. Coulomb for time. LHS value is how much? LHS value is how much? 1. Then 1 equal to LHS equal to RHS na. It means 1 coulomb of charge per 1 unit of time. Simple. LHS is 1. RHS also same only. 1 ampere is nothing but 1 coulomb of charge in a 1 second of time. Simple. 1 ampere. If you want to get 1 ampere current, 1 coulomb of charge in a 1 unit of time, you will get 1 ampere current. Clear? Next, the instrument measured. What is the instrument? If current passes through the body. Okay, let us take, this is a wire, current passing through the wire. How can I calculate? I will hold it. Okay, 2 coulomb charge passes, 4 coulomb charge passes. Can I calculate like that? Is it possible to calculating like that by holding a body? No, right? Okay. So, what is the device we use to calculate the amount of current? What is the device we will use? We will call as ammeter. What is the name? Remember? Ammeter. Okay, ammeter. So, this ammeter is help us to find out the current in a given circuit. Okay, for example, I am taking a one circuit here, one battery, and circuit having a resistance. If current is passing through the circuit, how much current is there? I would like to calculate how much current is present in the circuit. How can I calculate? I will put an ammeter. Then by the ammeter, I will calculate how much current is present in the circuit. Clear? Next. In a circuit using metallic wires, electrons constitute the flow of charges. Which are constitute? Electrons are constitutes in metallic wires. Why? In metallic wires, more number of free electrons are present. Okay, highly free electrons are present in a metals. Okay, in metals, highly free electrons. Free electrons means it's comes out of the atom. It comes out of the atom. Okay, if you take an atom, this is the nucleus and this is the outermost cell. This is the outermost cell. If the electron is present in the outermost cell, which electron present in outermost cell? This electron we called valency electrons. Valency means outermost cell. Okay. For example, if this electron comes out, the electron comes out from the valency shell. These electrons we called free electron. Okay, free electrons means the electrons comes out of the. Okay, I am a free bird means there is no responsible, nothing is present. Free bird, it's completely free. Enjoy. Okay, see, metallic wires, more what it is present, more number of electrons present, highly present, consisting of electrons. Okay, electrical wire not known at the time when the phenomenon of electricity. Okay, when discovered electricity at the time, there is no chance to find out an electron. Later they discuss. Okay, next, electrical current was considered to be the flow of positive charge. When they know, before they don't know about electricity, flow of electrons. Okay, later on they know it. That's why they consisting that electricity is the flow of positive charge, and direction of flow of positive charges was taken to be direction of electrical current. Okay, if electrical current is passes through a given wire or a conducting wire, connected to the battery. Okay, what we will consider electrical current. Okay, current having a direction na, electrical current as a direction. How can you represent this direction? The direction you represent the positive, okay, flow of positive charges. Okay, flow of positive charges. See, from the positive terminal, the flow will be there like this, positive to negative. Okay, the flow will be positive to negative. So this positive charges flow is considered as electrical current. Okay, the positive charges flow is considered as electrical current. Remember, if someone asks you what is the direction of electrical current, what is the answer? The positive charges flow is the consider of electrical current. And what about electrons? Electrons also present na? The electrons travels opposite direction. See, this direction positive charges will be there means opposite direction negative charges are present. These negative charges what we called electrons, which are present with the negative charge, electrons only na. So if positive charges are going like this, electrons are going like this, both are opposite. Okay, if you represent the direction of current means we have to consider positive, because from the earlier onwards we are taking only positive. Okay, what about electrical current? That is opposite direction of positive current. Clear? Yeah. Next, so electrical current is taken as opposite to the direction of flow of electrons. Okay, flow of electrons. Electrons started with the negative terminal and going opposite direction to the positive terminal. Okay. Next, see, an instrument called ammeter. What the ammeter will do? It measures amount of current present in the circuit. We already discussed. Okay, the device measuring that how much current present in the circuit is that ammeter. Okay, how ammeter is connected? The ammeter always connected in series. Remember how the ammeter connected? The ammeter is always connected in series. All of you may have doubt. Okay, you also get from chat box, sir, why ammeter is connected in series? I said na, you will get a doubt, right? So from the chat box we get a doubt why ammeter is connected in series. See, first of all, series connection means what ma? Series connection means I am taking a one bulb. Okay, this is the bulb symbol na? Okay, and I am attaching one more bulb here. How connected? End to end. So the connection is end to end, then it will be series. Remember, series means end-to-end connections. End-to-end connection. For example, I am taking one cell in a torchlight, positive terminal, negative terminal. One more cell connected here. Again positive terminal, negative terminal. One more cell I connected here. Again positive terminal, negative terminal. How the connection will be? Positive, negative. Okay. Positive, negative, positive, negative, positive, negative. Connection will be see. Positive, negative, positive, negative, positive, negative connected na. So it is called end-to-end connection. Okay. What is mean by end-to-end connection? Connecting alternately, positive, negative, positive, negative, positive, negative, end-to-end connection. How the ammeter is connected? Always in series. Remember, star mark given. Ammeter is always connected in series. Okay, because ammeter measures amount of current present in the circuit. Amount. Where you calculate amount? In a total circuit, na. If you want to get a total circuit current, means the ammeter always connected in series only. Okay, ammeter always connected in series because you are getting the total amount of current through the circuit. How much current? Okay, for example, if I am taking a divide into two path, if I divide into two path, okay, how it will be? Here the current is enter, right? Here the current is I1, okay. Here the current is I2. So at this point O, current divided, current splitted into two parts. If I connected ammeter, I will get this current only. If I will connect ammeter here, I will get this current only. Okay, so if I need total amount of current through the circuit, okay, how much flow will be present in the circuit, then it means I have to connect always in series. Always connected in series only. Okay, always connected in series. With the resistance also, you will connect it in series only. Next, electrical current flows from positive to negative terminal. Okay, electrical current where to where it go? Positive terminal to negative terminal. Positive terminal to negative terminal. Okay, next, look at the question. Look at the question. Get ready for answer. Understand now why we connected ammeter in series. Okay, if you want to get the total amount of current, okay, by the circuit, how much current will be present in the circuit? Ammeter. Okay, for example, in domestic purpose also, ammeter is there na. Okay, to your home, how much current you are getting? Where you will see? Ammeter only. How the ammeter is connected? Where it is connected? So series only na we connected. We connected ammeter always in series. If you want to get the total amount of current. Okay. Next, look at the question. Write the given information. Write the given information. A current. How much current? Current means flow. Current means flow. Okay. How much flow is there? 0.5 amperes. Where the flow will be? Drawn by a filament of an electrical bulb. So let us take a bulb. I am taking a bulb. Okay. Current is passing through the bulb. How much I flow is there? If current passes, bulb glow. How much current? 0.5 amperes of current given to the bulb. What happened next? Bulb for 10 minutes. How much time? Even in my home also, I add the bulb. I switch on the bulb for 10 minutes. How much current is passed? Let us take 0.5 amperes only. How much connected is this? Time is 10 minutes. 10 minutes is switch on only. Bulb is on. Okay. These 10 minutes, 0.5 amperes current is passing. Okay. 0.5 amperes of current is continuously passing for 10 minutes because the current is steady current. Okay. Next, find the amount of electrical charge. So, how much charge is passing that you want to calculate? How much charge is passing that you want to calculate? What is the formula? What is the formula? I is equal to Q by T only, na? Simple. I you know, time you know, you don't know charge. So Q charge is equal to I into T. Simple. Like that only, na? What do you want to find out? Charge. Charge is equal to I into T. How much current? 0.5 amperes. And time 10 minutes. See, 0.5 ampere is the SI unit of current. 0.5 ampere is the SI unit of current. And 10 minutes. So converting into SI units, 60. So 0.5 into 600. It means simply calculate 5 into 60. 300 coulombs of charge. How much charge is present? 300 coulombs of charge flows through the bulb. That's it. Okay. How much charge? If I am connected ammeter here in a circuit series, how much it will show? How much current it will show? That 300 coulombs charge passing. 300 coulomb charge passing, and how much current in the ammeter? 0.5 ammeter shows in a ammeter. 0.5 ammeter. Okay, 0.5 amperes current shows in the ammeter. Next question, define SI unit. We have two units, SI unit, CBSE unit. SI unit of electrical current. Electrical current formula what? Electrical current flow per unit time. Flow, coulomb. Okay, time, second. Coulomb per second, ampere. So ampere is the SI unit of electric current. Simple, enough, right? Very simple. Okay. Next, electric potential. Electrical potential. So this topic is little bit clumsy. Okay, don't confuse. Okay, don't confuse. Focus the class. Then if you have any doubt, you can comment in the chat box. I will help you to explain the answer. Okay, electric potential. Electrical potential. Every person having some potential, right? You are also having some potential. I also having some potential. Okay. So how can we calculate that potential? For example, if I am running, okay, 100 meter. If I am running 100 meter, I am taking for that 100 meters, I am taking 10 seconds. Is it possible? Okay, let us think. Okay, I am a Superman. So 100 meters travel in, let us take 5 minutes. 100 meters in 2 minutes. The same 100 meters you traveled in 1 minute. Who is more potential? You or me? Anybody from comment section? Sir, I have more potential. See, they have more potential, right? So how can you calculate the potential? What is the work? And how much time you take into completing that work? That is the calculating the potential. How can you calculate the potential? How can you calculate the potential? Work done. Simply power you take, work done per unit time. You have more power. Okay. See here. Here which potential? Electrical potential. Electrical potential. What it is doing? Amount of work done. What they calculating that? Amount of work done carrying which charge? A unit positive charge. Carrying a unit positive charge. For example, I am taking a plus Q naught. It's a point charge. Which charge? Point charge. Which charge it is? Point charge. Yes, ma. Yeah, from comment section, sir, what is point charge? What is point charge? So point charge is nothing but, for example, if you are seeing me very near a distance, how I will be? How I will be? My height is this much. Okay, you can see, right? If I will move 10 meters, how it appears? Little small I will appear. If same, I will travel 20 meters. What happened? Size will be decreases now. So where I will appear like a point, that means if you are seeing a long distance from me, if you are seeing me from a long distance, how I will appear? Like a point, chota wala, right? So point. So here point charge is nothing but the charge also the same thing. If I am seeing that a point charge is nothing but compared to the size, okay, compare the distance with respect to size, it will be less. Okay, for example, I am standing here. If I am going away from the A, you are here, you. I am going away from the A. What happened? At somewhere I will appear like a point now. How I appear like point? Because this size, a dimension of the body compared to the distance is very less. That's why it is appearing like point. So here also point size is nothing but distance will be more, much greater than the size. So that's why it is a point charge. What we are doing? This point charge, we are working on this point charge. What we are doing? Working on this point charge. Where it is? Where it is? It is at infinity. Where it is the point charge? It is at infinity. From infinity to, there is some charge. Let us take Q plus capital Q. Okay. There is some charge plus Q. From infinity to some distance, let us take. From infinity to some distance, we are bringing the charge from here to here. What we are doing? We are doing work. What work we are doing? Bringing a unit positive charge from infinity to a point under an electrical field. So this body is having electrical field now. This body is having electrical field, right? So this is the electrical field of this body. Okay. So in this electrical field we bring. For bringing from infinity to at a point, okay, at a point in the electrical field, from infinity to this point, how much work you are doing, that is called potential. Okay, simply potential is nothing but what? Working on a point charge from infinity to at a point in the field, that is called potential. Okay, next, an external electrical force. How it will become? By external electrical force only, na? Next, potential is which quantity? Scalar quantity. Potential is which quantity? Scalar quantity. See, potential. How the potential will be scalar? Anybody get it out? Yes, in comment section I already have a comment. Sir, how potential will be scalar? Have a doubt, na? See, how potential will be scalar? Potential is nothing but what, ma? Work done per unit charge. Okay, I am taking a Q naught is a point charge. On this point charge, I am doing work done. That is called potential. That's it only, na? Potential is nothing but on a unit point charge, I am doing work. What working? Bringing from infinity to at a point in electrical field. This is called potential. Work done is what? Work scalar only. Work is what? Scalar only. Charge, that is also scalar only. Scalar by scalar. Potential is also scalar only. Clear, na? Very simple. Okay, very simple. Next, what makes electric charges to flow? What makes electrical charges to flow? So you may not get this kind of doubt. Okay, you may not get this kind of doubt. Why electrical charges are flow? Huh? Have you get this kind of doubt whenever you studying about electricity? Anybody? Anybody from comment section? No, sir. No one get this kind of doubt. Okay. See, for example, let us take this is a tube. What is this? What is this? Comment sections. Sir, it is a remote. Assume. Okay. Assume. What is this? Assume it is a pipe. Okay. Horizontal pipe. Water is passing through the pipe. See, If I hold like this with the same height, if I hold like this, water will be there. Okay, this is also open, this is also open. Which side water flow? Which side water flow? Water will flow? Never. Water will constantly present. Water will constantly present. See in comment section how it will be. Sir, if you use more water, it will flow. No, my dear. Take less amount of water only. Okay. I am taking a very less amount of water in a pipe. If I will be like this, what happened? Water flow this side, right? Or if I will tilt like this, water flow this side. So what happened? Water is flowing. When height difference is there, then only water is flowing. Okay, if height is, there is no difference in height from the surface, same height, right side also, left side also same height. If there is same height, there is no flow of water. Okay, if difference in height, either this side or this side, it will go. Understand now? So even electricity also same thing only. If charges flowing means here no height difference, here potential difference is there. Here potential difference is there. For example, if I am taking a battery, if you buy a battery, they will mention 20 volts. What is this 20 volts? If you buy any electronic device, they will mention a voltage, right? They will mention a voltage. So how you calculated that voltage? What it gives that voltage? That it is nothing but, okay, here it is positive terminal, here it is negative terminal. So positive terminal have higher potential, negative terminal has lower potential. Where to where charge go? Higher to lower. It means here what difference is there? Potential difference is there. Because of this potential difference, charges go from higher potential to lower potential. If I am taking a pipe, where to where go? Here to here, because this is more height. So higher potential to lower potential. Okay, electricity charges moving means because of a difference of electrical pressure. Difference of electrical pressure is called potential difference. Okay, charges doesn't flow by itself. Remember, when it is connected to the battery, then only the flow will be there. Okay, when it is connected to the battery, then only. Otherwise, if you are not connected to the battery, I am taking a one metal wire, charges will be there, but there is no movement. Clear? Next, the difference of potential may be produced by battery. Okay, how the potential difference comes in a electrical wire? Because of battery. Okay, a battery connected means what the battery will do? Doing a work on charged particles, moving a charge from one end to another end. This is the work done by battery. Okay. Next, the potential difference set the charge in motion. See, very important point. Very important point. If there is a potential difference, this potential difference allows the charge is in motion. See, if height difference, then only na flow will be there. Here, if potential difference is there, then only the flow will be there. Clear? Next, and produces an electrical current, right? So we define the electrical potential difference between 2 points. How can you calculate it? If charge is going from one point to another point, let us take this point is A and here B. Charge moving from A to B na. At A one potential, at B one potential. So here potential difference is there. Okay, potential difference is there. If you think at A potential is VA, at B potential is VB, potential A is equal to potential B means there is no flow. Okay, there is no flow. When the flow will be there, potential difference is there, then potential flow will be there. Okay, next, work done to move a unit charge from one point to another point, what we call electrical potential. Okay, electrical potential, potential difference and potential. Remember very carefully, a small difference is there. Potential means from infinity to at a point. Potential difference means if you take a circuit between any 2 points in the circuit, A to B or B to A, at any point potential difference will be there na. That potential difference, okay, that is the potential difference at any 2 points is in a circuit, that is potential difference. From infinity to at a point, that is potential. The potential means infinity to at a point. Potential difference means any 2 points in a circuit. Between that two difference we call potential difference. Next, potential difference is equal to work done by charge. Work done unit joule, charge unit coulomb, charge per coulomb we called volt. Charge per coulomb we called it is that volt. Okay. Next, it's a SI unit. Next, 1 volt. Previously 1 ampere. Now 1 volt. Okay. Previously 1 ampere. Now 1 volt. 1 volt means volt. Potential formula. Work done per unit charge na. Work done per unit charge. 1 volt. How much you require? 1 volt. It means 1 into V. How much LHS? LHS is equal to RHS na. Anybody? Yes, in comment section they are very fast. Sir, 1 unit charge, 1 joule of work. It is called 1 volt. 1 coulomb of charge. 1 coulomb of charge. On 1 coulomb of charge, we are doing 1 joule of work. Okay, and 1 coulomb of charge. For example, this remote is 1 coulomb of charge. Okay, I am moving 1 coulomb of charge. On this 1 coulomb of charge, how much work I did? 1 joule of work. That is called 1 voltage. Simple. 1 by 1. 1 only. 1 joule per 1 coulomb. It is called 1 volt. Okay. Next, potential difference is measured by means of instrument called voltmeter. How the current will be measured? Ammeter. Current measures ammeter. Potential difference measures voltmeter. Ammeter, how we connect? Series. Series means end to end connection. Voltmeter, how we connect? Voltmeter is always connected in parallel. Remember, you will get 2 questions. Okay. Ammeter, how we connect? Series. Voltmeter, how we connect? Parallel connect. Okay. How connected? Parallelly we connected voltmeter. Okay. That means if you take in a 2 circuits here. Okay. So if I need to get difference between A to B, how I connected to the circuit? How I connected to the circuit? If this is a circuit, how I connected it is? How I connected it is that? Okay. See, how I connected here it is that? How it is? Parallel. Okay. How we connected voltmeter? Voltmeter always connected in parallel. Ammeter always connected in series. Okay. Next, how much work is done in moving a charge of 2 coulombs across 2 points. Let us take 2 points. I am taking A. Okay, 2 points. A is 1 point. B is 1 point. A to B, what I did? How much charge from A to B? From A to B, how much charge from A? It is having 2 coulombs charge. At B also, from A to B, I drag the charge 2 coulombs. Okay, from A to B. At A is there, at B. Okay, from A to B, how much charge? 2 coulombs of charge moving from 2 points, A to B. How much potential is applied moving from A to B? How much potential is applied? How much potential? 12 volts. Okay, here A to B, I moved a charge. How much work I done here, that I would like to calculate. How much work I did here, that I would like to calculate. Formula, voltage I know, work I don't know, charge I know. Then W is equal to voltage into Q na. Voltage 12, charge 2, 12 to 24. So 24 joules of work is required moving from A to B. Okay, is having a 12 volts of potential. Clear? Clear? Next, have a break. It's your favorite time. Okay, it's your favorite time now. Everybody enjoy the break. Hey, have a break, 2 minutes. After the 2 minutes, again we start the section with same energy. Okay, yeah. Welcome back to the section. Break is enough, right? Yeah. So you enjoy the break? Had something? Okay, yeah. Without any delay, can we start? Yes. Yeah. Next, circuit diagram. Okay. Really, the circuit is required or not? Circuit is required or not? If I would like to go from one place to another place, what it is required? A path is required, na? So similarly, here in circuit diagram also, the circuit is nothing but it's just like a path. Okay, just like a path. See how what are the components are there? Battery is present. What are the components are there? Battery is present. Through the battery, current is passing, and where it gone? Here it is. A bulb is connected. When the current is passes, bulb flow. See how the ammeter. What is a ammeter? How the ammeter is connected? See, plus negative. Okay, again plus negative. How it will be? End to end connection. If it is end to end connection, which one it is? Series connection. Okay, series connection, and K is the plug key. K is the plug key. See, a graphical representation of electrical circuit. Circuit diagram is nothing but it's a graphical representation. Okay, if it is not graphical, if I would like to draw a bulb, maybe for you it is possible. For me, it's not possible to draw. For many members it's not possible to draw all the diagrams like switch, okay, resistors and bulb. So many electrical components it's not possible to draw the diagram. That's why we follow that graphical representation. For suppose here by seeing this symbol, seeing this symbol, what we can assume in our mind? What we can assume? There is a bulb. Okay? Yeah. Next, look at the symbols. Look at the symbols. Look at the symbols. Okay, remember that. Important to know the symbols also. Sometimes you need to draw the circuit diagrams also. Okay. Electrical cell. Cell means one positive, one big terminal, one small terminal. One big terminal, one small terminal. Next, battery. Battery is nothing but combination. It means plus, minus, plus, minus, plus, minus, plus, minus. It's battery only. Combination of cells, battery. Okay, remember, cell is a single, battery is a plural. Okay, combination. Next, switch open or plug key open. See, look at the difference. Here, there is a dot. If dot present means it's closed. If there is no dot means it's open circuit. Okay, switch on, switch off. Both will be there now. On means circuit is closed. How can you represent? Okay, for suppose there is a switch here. I on the switch. How can you represent the diagram? With a dot. Open means no dot. That's it. Simple. Next, wire joint. If you joined any 2 or 3, see, point, joint. Okay. If crosses the wire, one by one, crosses means this is the symbol. Okay. Next, electrical bulb. See, symbol. If the bulb glow means like this. Next, resistor. Resistor. If you know the resistor means that symbol, it come automatically in our mind. Okay, in our mind we will get automatically. What is the functioning of resistor? Opposing. Okay, opposing the movement of electron. If you are going on a road, what will be present? Speed breaker. Like this only, na? Like this only. What will do? Control the speed. Control the speed. So this is the symbol. Here resistor symbol also the same. Next, variable resistance. Variable resistance. So if you go in road also, sometimes I speak. Okay, speed breakers will be like this. Like this only, sometimes speed breakers will be. See, if bike is going here, moment will be slow. And coming to here, compared to A, it be some better. Compared to B, it C some better. Compared to C, a D better. So, how the flow will be? At different points different, right? So, here also variable resistance means the current flow will be different. Okay. Next, ammeter. Symbol you know, A. Voltmeter. Symbol O. Okay. Next. Ohm's law. Very, very important. Okay, in introduction also we said Ohm's law. It's very important. Okay, if you understand Ohm's law, based on that Ohm's law, we have numericals. Okay, and concept based questions. Okay, can we start the Ohm's law? Yes. See, Ohm's law is what? Relation between current, voltage, and resistance. How many variables are there? 3 variables. Current, voltage, resistance. Relation between among these 3. For example, I am taking one conductor. Okay, let's connect it to the battery. Okay, when connected to the battery, through the circuit, potential difference will be there na. At A one potential, at B one potential will be there. Current is passing, charge is passing through the conductor. Charge is passing through the conductor. This experiment we do that at a temperature constant. Okay, at temperature constant, how much potential? Okay, how much potential difference we given to the wire, that much current will be there. So Simply potential difference increases, flow also increases. If potential difference decreases, flow also decreases. Both are proportional each other. Both are proportional each other because I is what ma? I is what? Flow. Flow where depends? It depends on the source, right? Flow depends on the source only, na? Flow depends on battery only, right? If I am taking a 10 volts battery connected to a LED bulb, 20 volts battery connected to the LED bulb, difference is there or not? What difference will be? LED light is same. 10 volts, 20 volts. What difference is there? 10 volts is there. Charge flow for time. 20 volts. How the charge will be? Flow is different, right? Okay. If source changes, simply source changes, flow also changes. Source changes, flow also changes. If I am going on a cycle, the flow will be different. If I am going on a bike, flow will be different. If I am going on a car, flow will be different. Okay. So why the flow is changed? Because vehicle changed. Okay. 150 cc, 120 cc, 100 cc, 350 cc, right? So flow changes based on the source. So what is the source here? Voltage is the source. Where this will be happen at constant temperature. If you remove the proportionality, what you will get? Or you will get V is equal to Ri. What is our resistor? What is our resistor? Look at here, the potential difference V across the end of given metallic wire in electrical circuit is directly proportional. Okay. Electrical potential is directly proportional to the electrical potential directly proportional to the current. V proportional to I. Remove proportionality, you will get a resistor. Okay, you will get resistance. So the symbol of resistance, the unit of resistance is ohm. What is the unit? Ohm. O-H, ohm. OHM. Ohm, it is the unit of resistance. For example, your friend asks you what is the unit of resistance? Oh, enough. You get the answer, ohm. Okay. What is the unit of resistance? Even we are thinking also, you will think that you get sound na? Ohm. That's it. Ohm is the unit of resistance. Okay. And the symbol is like this. This is the symbol of resistance. Okay. Next, see how the graph will be. How the graph will be. See, what is Ohm's law? V proportional to I. V increases, current also increases. See, current on the x-axis, potential on the y-axis. Potential increases at 0.4. Current also increases. Okay. How it will be? Straight line. How it will be? How it will be? Straight line. If I am taking an angle here, theta. If I am taking an angle here, tan theta is equal to opposite side by adjacent side. Na? Opposite side is what? Opposite side y components only. y1, y2, y3, y4. Y components only. Adjacent side x components, y by x. Y is what? Voltage. X is what? Current. So V by I, that is resistance. V by is what? Resistance only. Clear? Okay. See, V by is what? Resistance. So, at a given temperature, these all the experiments done at a temperature constant. If temperature varies means what happen? Whenever we connected, let us take a conductor connected to the battery and potential difference is created at the end of the conductors. Then the flow will be there. This all the things will be takes place on at constant temperature. For example, temperature changes. If increase in the temperature, what happen? The flow is not, it's different, it's changes a flow. Why? If temperature increasing means, for example, if temperature increases, the electrons comes out, right? More number of electrons comes out from the atoms, na? the flow will be changes, the flow will be different. That's why what is the Ohm's law said? At constant temperature, the given potential is directly proportional to the flow of the current. Okay, remember, at constant temperature only, or okay, at constant temperature V directly proportional to the flow of the current. Okay, potential difference across the wire increases linearly. This is called Ohm's law. Okay, see how it will be increasing now. Linearly, how the increasing will be? Linearly. How much potential is there? That much current is there. Increasing linearly. Okay, next. 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 How does the current in a circuit changes if the potential difference is doubled? Anybody from comment section? Anybody? Huh? What is the question, ma? What is the question? Solution. Write the given. Write the given. How does the current in a circuit changes? So I am taking a circuit. How much potential? Let us take V. Okay, connected to the bulb. Okay, so if V is there, current is I. Okay, how does the current in a circuit changes if the potential difference is doubled when keeping the resistance is constant? Keeping, what is the formula? V is equal to I R. What is our resistance? What is our resistance? Keep resistance constant as per the question. Keep resistance is constant as per the question. If keeping a constant, what happen? In place of constant, one symbol will come now, proportional symbol. So V proportional to I. V proportional to I. That only now Ohm's law. If voltage increases, current also increases. When? At constant. So V, what is the question? In question, potential increases, then current also increases. How much potential increases? Potential increases twice. Current also increases twice only, that's it. 2V proportional to 2I. If potential increases, flow also increases. Okay, when? At constant temperature or at constant resistance. Clear? Yeah. Next, resistance of a conductor. Resistance of a conductor. So most of them don't know about resistance. Okay, so what is meant by resistance? Okay, in general, if you take an example, you are going on a bike on a road. Okay, you're not having a helmet, someone will stop you, right? Okay, someone will stop you now. They are doing opposition. Our speed breakers will be there. What it will do? If you are going with a high speed, what the speed breakers do? Control the speed, reduces the speed, right? So even if you take a conducting material, in conducting materials also speed breakers are there. Okay, in conducting materials also speed breakers. Electrons are moving in opposite direction now. Okay, when a metallic wire is connected to the battery, electrons are moving opposite direction to the positive current, right? Opposite direction to the positive current. When electrons are moving in a metal, positive ions are there. So these electrons come and collidal with the positive ions. So when it is collidal with the positive ions, what happened? Its speed reduces. Okay, the electrons movement are opposite. So this property is called resistance. Okay, so what is the property of a conductor? Resist. What resist, ma? Flow of charges. Resist the flow of charges is called resistance. Resist the flow of charges is called resistance. So if the potential difference across the two ends of conductor, okay, when it will be 1 ohm, tell me, when it will be 1 ohm, 1 ohm of resistance, V is equal to IR. Okay, R is equal to, we can write V by I na. What we required? 1 ohm. 1 ohm. 1 ohm of resistance we required. Anybody from comment section? Yes, they are very fast. Okay, 1 ohm. 1 ohm means 1 ohm. LHS is 1 ohm. It means RH is 1 volt by 1 ampere of current. 1 volt by 1 ampere of current. Then you will get 1 ohm of resistance. Simple. Okay, if you get 1 means LH is 1, RH is 1. Simple. Okay, next, look at the property. How the property will be? Property of a conductor opposes the flow of electrical current. See, look at that. How the electrons are going like this, in this direction. Electrons are going in this direction. How the opposition will be? Opposite direction. Electrons, if electrons are coming, stop. Okay. So, electrons are going, stop the electrons. That property we call it is that resistance. Okay. What is the resistance? Simply opposes the flow of electrical current. Is called resistance. Resistance unit is what? Scalar only. Resistance unit is what? Scalar. Why it is scalar? R is equal to V by I na. Potential is what? Scalar. Current is what? Scalar. Scalar by scalar. Scalar only you will get. Okay. Next, unit ohm. We know it. Next, the moving of electrons. Okay. Moving of electrons collide with each other. Okay. Moving of electrons. One electron, another electron. Okay. Collide. One electron, another electron collided. Or the electron collided with other particles also. Electron collided with the other particles. Which are present? Other particles means ions are present. Na? So it is collided with other particles. This property is called as that resistance. Okay. Positive ions present in the metallic conductor. Okay, itself collided each other and it collided with the positive ions also in a conductor. Okay, next, see, this collision tends to slow down the speed of the electrons. After collision, what happens? For suppose, if I am moving, I collide with the bench, what happens? Can I move? I will move like this only, na? I will not move much fast, right? So, here also, after the collision, what happened? Slow down the speed of electrons. Okay, hence this slowdown means what? Opposing the flow of electrical current. Look at there, look at the diagram. If you look at the diagram, you understand better. See, electrons moving, collided with other electrons or collided with the positive ions. So what happened? Whenever the collision takes place, opposes the movement of free electrons. That property is called as the resistance property. Whenever temperature increases, what happen? Whenever temperature increases, what happen? Okay, if the temperature increases, electrons move much fast, na? Electrons move much fast. Electrons move much fast. Then collision takes place. Maximum number of collisions takes place. High number of collisions takes place when temperature is increases. Clear? Next, what are the factors? Resistance depends. What factors resistance depends? Resistance mainly depends on 3 factors. Okay, it depends upon the length. Okay, and it depends upon the area of cross section, and it depends upon the nature of material. Okay, if length is L, if I extended, resistance changes. If area is A, if I extended area, resistance changes, or decreases the area, resistance changes. Okay, and if I am taking a plastic and wood, resistance will be differ, right? Resist, if we are having same length, this is also L, this is also L, this is also A, this is also A, but look at the nature of the material also. This is wood, this is plastic, both are same nature? No. Then resistance will be differ. Okay, what are the factors of resistance? Depends on length, depends of area of cross section, depends upon the nature of material. Okay, remember LN, Lakshmi Narayana sir, me only. Okay, it depends on length of the conductor, it depends on nature of the material, Okay, length nature, and it depends upon area of cross section also, LNA. Okay, length, nature of material, area of cross section. Okay, the resistance factors are, remember my name, Lakshmi NA, Lakshmi Narayan. Okay, length, nature of material, area of cross section. Next, see, length L. Here length double. Length increases. Resistance is directly proportional to the length. Resistance is directly proportional to length. Length increases, resistance also increases. And next, here look at the area. Area A, here area is 2A. Area increases, resistance decreases. It means resistance increases, area decreases, or area increases, resistance decreases. Why? Because if you take a street roads, how the area will be very small. If you take a highway, how the area will be more. That means if area is more, we can move freely. Right. If the area is less, no space. Okay. So area is less, more resistance will be. Okay, because collisions will take place, I write. Area is more, less number of collisions. That means resistance is less. Next, and depends upon the nature of the material. Okay, nature of the material. That nature of material we call as that resistivity. Okay, see, R depends on L, depends on area. Remove the proportionality. In place of proportionality, you will get constant. That constant we called as that resistivity. What we called rho? What we call that rho? What we call resistivity we called. Okay. What we call resistivity. So resistivity is what? It's a material of the conductor. Okay. Electrical resistivity is nothing but what? It's a material of the conductor. Which material you take? Okay. It depends upon the nature of the material also, right? If you take plastic, how the opposition will be. If you take wood, how the opposition will be. Okay. It's a resistivity of the material. Next, and unit rho is equal to RA by L. So area, how can we write? L into L na? By L. LL cancel. Resistance unit ohm. Length unit meter. So ohm meter is the unit of resistivity. Simple. Ohm meter is what? Unit of resistivity. Clear? Next. Yeah. Now look at that. Metals and alloys have low resistivity. Okay. Which are having low resistivity? Metals and as well as alloys. Okay. Alloys nothing but mixed of metals. Okay. Mixed of metals or mixed of materials. Mixture of metals or mixture of materials is known as alloy. So how the resistivity will be? Low. How the resistivity be? Low resistivity. Okay. How the resistivity in metals and alloys? Low resistivity. Okay. How much will be? 10 to the power of minus 8 ohms and 10 to the power of minus 6 ohms. This is the resistivity of alloy and as well as metals. How much? 10 to the power of minus 8 and 10 to the power of minus 6. Next, insulators. So insulator nothing but rubber, glass, plastic. How the resistivity will be? 10 to the power of 12 to 10 to the power of 17 ohm meter. How the resistivity will be? Huh? How the resistivity will be? See, resistivity means what? Opposition will be takes place. Okay, here free electrons, no free electrons are present. Okay, so I am taking a wood. Here. Okay, how the atoms and molecules gap is there between one molecule to another molecule, gap is there. Whenever, see, if for example, if I am taking at a temperature T. Okay, I am taking at a temperature T degrees Celsius. If I am increasing the temperature, what happened? From the atom, electrons come out na? From the atom, electrons come out. So if you increase the temperature, resistance decreases. Okay. Why? If you increasing the temperature, number of electrons comes out. Electrons coming out. Okay, if an electrons comes out, will be because of that amount of heat, it will flow now. Electricity will be there, right? Okay. Next, resistivity of an alloy is generally higher than of metals. How the resistivity will be? High. How the resistivity will be? I remember. Okay. Which one is having high resistivity? Alloys are high resistivity than metals. Okay. Next, see here we have few materials. Here you have few materials. Look at that, which is having high resistivity and which is having high resistivity. Look at that, which is having high resistivity. Which is having few materials are there, right? Look at that, examples of conductors, alloys, insulators. Okay, insulators which are there? Glass, rubber, plastic. These all are insulators only, na? And conductors, silver, copper, aluminium, tungsten, nickel, iron, mercury, manganese. Mostly all the metals are there in conductors. Okay, these are the values of resistivity of the materials. So you have to find out that which is having high resistivity and which is having low resistivity. How the resistivity will be, okay, in different materials of conductors and in alloys also. Okay, alloys are nothing but is mixture of materials or group of materials. Okay, so which are present? Constant. Okay, nickel. Okay, constant means it's mixture of copper and nickel. Manganese, copper, nickel. Okay, so it's a mixture of materials. Alloys is nothing but mixture of material. Next, insulator. Glass, we know insulator is nothing but wood, plastic, glass, diamond. Okay, paper. These are the insulating materials. So see which is having high resistivity and all. Okay, find out that from the table which is having high resistivity, which is having low resistivity. Look at those two only, because in a classroom we will focus on which is having more topper, which is having a topper and which is having low score. These two only, na? Even in the table also we will notice that which is having high resistivity value, which is having low resistivity value. Only two. Okay. Next, yeah. Next, see, look at a question. Look at a question. Read the question first of all. What given? What is the given information? Okay, if the question is given, don't worry. Write the given information. If you write the given information, half of the problem is solved. Okay, any question from the physics, any topic. Okay, so write the given information. If you write a given information, then you will get some confidence. Okay, I hear something, I know about this. Okay, then you know which formula you have to use and which way you have to solve the question. Okay, so just follow the class, you understand. See, a wire of given material having length L. So let us take a wire. How much length will be? I am taking given information only. Okay, what it is mentioned in the problem, I am taking that given information. So how the length will be? L. Okay, and area of cross section. Area of cross section. A is there. Okay, and how much resistance is there? How much resistance? Resistance of this given material is 4 omega. Okay, 4 omega. And what would be the, see, and what would be the resistance of another wire? See, up to here, let us take case 1. And coming to the second case, case 1, what is given? Given a length of the material. Okay, resistance of the material, area of the material. And next, up to here completed. Next, what would be the resistance of another wire of the same material? Okay, material will be same material. If material is same, resistivity also same. Rho value is same. Okay, rho value is same because resistivity depends upon nature of the material only. Having length, see what changes takes place if this is L, another material is L by 2 only. Length reduces to half. Length reduces to half. And area of cross section. Area of cross section. Here area of cross section is A. Here area of cross section is 2A. Then, okay, what would be the resistance of another wire? Two wires are given, same material, one is having L, another one is having L by 2. One is having area A, another one is having 2A. Now see, what factors the resistance different? You know the factors, right? Just now we discussed. Resistance R is equal to rho L by A. This one in a formula. Rho value, same material, rho only. L, L only. A only. Here, this is take R1. R2. R2 is equal to resistivity rho only. Length of the material L by 2. Area of the material 2A. Then it will be rho L by A into 2 by 2. 1 by 2 into 2. 1 by 4. So rho L by A is what ma? That is the first material, right? So R2 is equal to R1 by 4. Then R1 is equal to 4R2. So comparing the two materials, R1 and R2, R2 having more resistance comparing with R1. Why? Same material na? Even same material also, resistance depends on what factors? What is my name? Lakshmi Narayan. Depends on length, depends on nature of material, depends on area of cross section. Okay? Yeah. Next, one more question. Why are alloys like manganese or constant are used for making standard resistors? Okay, making standard resistance. Okay, rather than pure metals. What you are making here? Resistors you are making. Then pure metals. So pure metals means how that resistance will be low resistance. How the resistance will be low resistance. And here high resistivity. How the resistivity will be? High resistivity will be. High resistivity will be. So high resistivity will be. High resistivity means opposing more. Where we are using? In resistors we are using. Where we are using? Alloys, where we are using? In resistors we are using. Why we are using in resistors? The two alloys we are using compared to the metals. Having any doubt? Why? Anybody from comment section? Why we are using alloys then the metals? Metals will allow easily, right? But here you have to identify making resistor. For making resistor. So what resistor do first of all? Opposing. Which one oppose more? Alloy or metal? Alloys are oppose more. Why alloys opposes more? Because mixture of metal. Whenever a mixture of material takes place, the order is in order. How the resistance will be? Right, high. How the resistivity will be? High. If resistivity will be high means temperature also increases. Okay, temperature also increases. If you take a heater, okay, or iron box, how heat comes? Because of alloy. Okay, you have high resistivity. If resistivity is high, the temperature increases because collisions are maximum number of collisions takes place. Temperature increases more. Then if temperature increases, if I am taking iron box, if there is no producing of heat, what is the use to make? What is the use to buy iron box? No use at all, right? Okay, yeah. So what is the reason? High resistivity compared to the metals. Okay, understood now? Next, yeah, and summary, what we are going to discuss in today's section. Okay, just recap quickly. Okay, see, introduction of charge. Charge is what? Intrinsic property, where it is present inside. If there is no matter, no charge. Matter is present without charge also, but charge is never present. Okay, for example, without oxygen, I will not present. But oxygen is present without me, right? Is correct only, na? Huh? Yes or no? Oxygen is present without me also. But I am not present without oxygen, right? Okay, so charge is present with the matter. Without matter, charge is never present. But matter is present without charge also. Next, conductors, insulators, semiconductors. Conductors means allow. Semiconductors means off allow. Insulators mean doesn't allow. Okay. So I have three friends. First person I given 10. Second person taken 5. Next person, okay. In 10 I am taking 5. Insulators, it doesn't allow. Okay, semiconductors are. Sorry. Okay, conductors allow. Semiconductors off allow. Insulator doesn't allow. Okay. Next, electrical current. Amount of current passing through a given time. Charge passing per unit time is called electrical current. Okay. Next, circuit. Circuit means it is a path. If I would like to go from one place to another place, from here to or Mumbai or Vijayawada or Hyderabad or any place, I would like to go by walk. No, na? I need a transport facility, right? So to move from one place to another place, charge also requires circuit. Next, electrical potential. Potential means infinity. Okay, I am giving a shortcut here. Infinity to a point. Infinity to a point. Potential difference. Potential difference between any 2 points in circuit. Any 2 points in circuit. Okay, potential difference nothing but any 2 points. Potential means infinity to at a point. Next, circuit diagram. What are the components are there? What are the component? Resistor is there, variable resistor is there. Okay, switch is there, open switch is there, closed switch is there, bulb is there, ammeter is there, voltmeter is there, ammeter connected in series, voltmeter connected in how? Anybody? Voltmeter how we connect? How we connect voltmeter? Huh? Parallel. Okay. Yeah. Next, Ohm's law. What is Ohm's law? V proportional to I at constant temperature. At constant temperature. Okay. Next, factors. What factors are there? What factors are there? If you are writing in the examination also, if they are asking about what factors the resistance depends, immediately you have to remember. Okay. What is that? Length, nature of material, area of the material. Okay. Yeah. So, this is summary. Yeah, that's all for today. I hope you all enjoy the section. Let's meet in the next class. Okay. Thank you all of you. Okay. Thank you all.